Very good morning to all of you. Myself Dr.R.C. Ramachandra Panda. I am giving coaching for engineering thermodynamics, fluid mechanics, engineering mechanics, and strength of material. That is mechanics solid. Today, our topic is engineering thermodynamics. I already done 35 number of classes and also done 110 number of problems. This problem is 111, 111, 111. This relates to first law of thermodynamics. I have already completed the theory topics, and now I am revising some problems regarding first law, steady Fluid equation, second law, entropy, and steam. But this problem relates to first law of thermodynamics. Clear? You try to understand. If any doubt, give comments. Thank you. Now come to question. The question is: a gas undergoes a thermodynamic cycle consisting of three processes beginning at P1 is 1 bar, B1 1.5 meter cube, U1 512 kilojoule. The processes are as follows: process 1 2, process 2 3, process 3 1. Process 1 2 compression with P usual constant to P to 2 bar, U to 690 kilojoule. Clear? Process 2 3 U230 and Q23 minus 150 kilojoule. Process 31 double 31 50 kilojoule. Very important question. Neglecting changes in K and P. Find the heat interaction during 1 2 and 3 1. That is Q1 2 and Q3 1. Find Q1 2 and Q3 1. Clear? Very easy question also. Important as well as easy. Now again come to given data. A gas undergoes a thermodynamic cycle consisting of three processes beginning at P1 1 bar, B1 1.5 meter cube, U1 512 kilojoule. Clear? So given U1 is equal to 1 bar. 1 bar means 100 kilopascal. Clear? 1 bar 10 to 5 Newton per meter square. 1 bar is equal to 10 to 5 Newton per meter square. Clear? This is equal to 10 to 5 by 10 to 3 kilopascal. 100 kilopascal. This 1 bar is equal to 100 kilopascal. Now our given data is 5 bar, 1 bar. So P1 is equal to 1 bar means 100 kilopascal. Right? Then B1 1.5 meter cube. B1 is equal to 1.5 meter cube. U1 512 kilojoule. U1 is equal to 512 kilojoule. Clear? This is the given data at 1. Now the process 1 2 consists of compression with the PB constant to P2 is equal to 2 bar, U2 is equal to 690 kilojoule. Clear? This process 1 2. Then process 2 3. Process 2 3 U230 and Q23 minus 150 kilojoule. U23 is equal to 0 and Q23 is equal to minus 150 kilojoule. Clear? This is process 2 3. Process 3 1 double 3 1 50 kilojoule. Double 3 1 50 kilojoule. Neglect changes in K and P. Delta K is 0, delta P is 0. Find Q12 and Q31. Now we will find out Q12, Q31. These two things we will find out. Clear? The two things we will find out. Now, first come to process 1 2. Process 1 2, PB is equal to constant. PB is constant. Clear? Now, P2 is equal to 2 bar, UT is equal to 690 kilojoule. What is P2 is equal to 2 bar, means 200 kilopascal. UT is equal to 690 kilojoule. Clear? Now constant temperature process. PV constant means constant temperature process. So what is what done? So W12 is equal to P1 V1 ln V2 by V1. Here V2 is not given, only V1 given. So it can also written by P1 V1 ln P1 by P2. Right? Because P1 V1 is equal to P2 V2. This process follows the law of PV constant. That means P1 V1 is equal to P2 V2. So what is P1 by P2 is equal to V2 by V1. So put here V2 by V1 is equal to P1 by P2 because we have P1 and we have P2. Clear? Now W12 is equal to P1 V1. What is P1? 100 into P1 1.532 ln P1 by P2. What is P1? 100 by P2 200. Clear? This is W12. W12 is equal to minus 103.9 kilojoule. Minus 103.9 kilojoule. You use calculator. Find this value minus 103.9 kilojoule. This is W12. Next, change in inclination delta 12. This is what done. Now change in inclination energy. Delta U12 means U2 minus U1. What U2? U2 694 no 690. 690 minus U1 512. Both are kilojoule, so the answer is also kilojoule. Clear? U12 means final means initial, U2 means U1. So this is equal to U12 is equal to 178 kilojoule. This is 178 kilojoule. Delta U12. Right? This is change in electrical energy. This is what done. We will find out heat interaction during 1-2. Heat transferred. So I have already told you the law of conservation of energy. What is Q is equal to? W plus del U. So for process 1-2, Q12 is equal to W12 plus delta U12. So heat transfer What Q12 is equal to? Double 12 plus value 12. Clear? This is law of conservation of energy. So Q12 is equal to double 12 means what double 12? Minus 103.9 plus U12 means 178. Clear? U12 is equal to 170 kilojoule. Double 12 is equal to minus 103.9 kilojoule. Right? So this is Q12 minus 103.9 plus 178. So Q12 is equal to 74.1 kilojoule. This answer is 74.1 kilojoule. Answer, one of the answer Q12. This is process 1 2. Then come to process 2 3. Then we will go to process 3 1. So Q12 is equal to 74.1 kilojoule. This answer. Now come to process 2 3. Clear? Process 2 3. Process 2 3. P2 is 2 bar, U2 690, double 230, Q23 150 kilojoule. Clear? So process 2 3. P2 is equal to 2 bar means 200 kilopascal. U2 is equal to 690 kilojoule. U2. U23 is equal to 0 and Q23 is equal to minus 150 kilojoule. This is process 2 3. Clear? Now, according to law of conservation of energy, Q23 is equal to W23 plus delta 23. Clear? Here delta 23 0. This is 0. So Q23 means minus 150 is equal to W23. So W23 is equal to minus 150 kilojoule. Right? No. The double 2 is not U. The double 230. Sorry. This is W230, not U23. Double 230. Yeah, given data is double 230. So according to law of conservation of energy, Q23 is equal to double 23 plus delta 23. Here double 230. Clear? So this is minus 150 is equal to delta 23. So delta 23 is equal to minus 150 kilojoule. Here delta 23 not 0, will find out delta 2 the double 230. Given data double 230. Clear? So what is delta 23? Now delta of 2 3 is equal to u3 minus u2. Clear? u3 minus u2. What is u3? u3. You find out. So this is minus 150. Minus 150 is equal to u3 minus u2. What is u2? 690. So what is u3 is equal to? Minus 150 plus 690. So u3 is equal to minus 150 plus 690. 540 kilojoule. Right? Again I repeat this. Clear? According to law of conservation of energy, Q23 is equal to double 23 plus delta 23. Here double 230. So this is minus 150 is equal to delta 23. Delta 23 is equal to minus 150 kilojoule. Or what delta 23 is equal to? U3 minus U2. Clear? So minus 150 is equal to U3 minus 690. This implies U3 is equal to 540 kilojoule. Clear? Next count process 3-1. Process 3-1. Now process 3-1. Q31 is equal to double 31 plus delta 31. First find out delta 31. Now or Q31 is equal to heat transfer double 31 plus delta 31 means UR minus U3. Final minus initial UR minus U3. You find out Q131. Q31 find out double 3 are given 50 kilojoule. UR is given, U3 also given. Now what is Q31 is equal to? Double 31 50 plus U1 minus U3. What is U1? U1 512 minus U3 540. Right? This implies Q31 is equal to 50 plus 512 minus 540. 20 50 plus 5 120. 562 562 minus 540. 22 kilojoule. Clear? This implies Q31 is equal to 23 kilojoule. Right? Very important question, also very simple question. Only we are using here law of conservation of energy. That is Q is equal to double ball delta U. What is Q is equal to? Heat transfer. What is what done? W. What done? Delta U change in energy. For process 1 2, Q12 is equal to W12 plus delta U12. For process 2 3, Q23 is equal to double 2 3 plus delta 2 3. For process 3 1, Q31 is equal to double 3 1 plus delta 3 1. Right? We calculate all the answers. Next, our question is 1 1 2. Clear? Now, This is question number 112. This is a very important question. Easy question. Only PV diagram. We will draw only PV diagram. Then apply this formula. Use your double bond delta U. Clear? Apply this formula law of conservation of energy. Then solve the problem. Very easy question, but important question. See, come to question. A gas undergoes a Thermodynamic cycle consisting of the following processes. Process 1 to constant pressure P1 is equal to P2 1.4 bar, B1 0.028 meter cube, and double 1 2 is equal to 10.5 kilojoule. This process 1 to constant pressure process. Next, process 2 3 compression with the PV constant, isothermal compression U2 is equal to U3. Clear? Then process 3 1 constant volume process, that is B1 is equal to B3, and UR minus U3 is minus 26.4 kilojoule. There is no changes in K and P. Delta K is 0, delta P is 0. Calculate the net work transfer for the cycle, total and heat transfer for 1 2, and prove that total Q is equal to cycle integral of dq is equal to cycle integral of dw. That means summation of Q is equal to summation of W. That is, prove that summation of Q cycle is equal to summation of W cycle. Clear? Now, first find out W12, W23, W31. Make summation of work transfer. Then find out Q12, Q23, Q31. Then make sigma Q. Then if both are equal, then the question is correct. Clear? If sigma dq is equal to sigma dw, or total q is equal to total w, then our answer is correct. First draw the figure. Now, a gas undergoes a Thermodynamic cycle consisting of the following processes. First draw the figure. This is PV diagram. Clear? PB. This is pressure P, volume V. Process 1 to constant pressure. One two. Clear? Process 2 3 compression with PV constant. Process 2 3. Then process 3 1 constant volume. Clear? Process 1 2, process 2 3, process 3 1. The closed cycle. Closed cycle means no energy transfer. Delta U total 0. So Q total is equal to double total. You will prove that Q total is equal to double total. Now, process 1 to Q1 is equal to P2 is equal to 1.4 bar. means 140 kilojoule, kilopascal. Clear? B1 is equal to 0.028 meter cube. Clear? Double 1 is equal to 10.5 kilojoule. This is for process 1 2. Clear? Then for process 2 3. This process 1 2. Then process 2 3. For process 2 3, Pb is constant, U3 U2. Clear? Then process 3 1. Process 3 1, U1 minus U3 is equal to minus 26.4 kilojoule. Clear? First come to process 1 2. Now for process 1 2, constant pressure process, so double 1 2 is equal to P into V2 minus V1, P dV. P means pure P2, P means pure P2 is P. Clear? So what is the process 1 2? 10.5 is equal to P 140 into V2 minus V1 0. Right? V1 0.0 not 0, 0.028, 0.028. So find V2, sorry, V1 not 0, V1 is 0.028. Find out V2 is equal to 0.103 meter cube, 0.103 meter cube. Right? Put W1 to 10.5 kilojoule, pressure 120 kilopascal, V1 0.02 meter cube. We'll find out V2 is equal to 0.103 meter cube. Clear? Then come to process 2 3. This figure, this is constant pressure process, this is Pb constant, this is constant volume process. Here, process 1 2 constant pressure, process 2 3 compression with the Pb constant, process 3 1 constant volume. Now the cycle is completed. This process 1 2, then come to process 2 3. Process 2 3 means compression with Pb is equal to constant. Now process 2 3. So process 2 3, P2 is this. Clear? What is U3 is U2 and B3 is B1. Here B1 is equal to B3. This is P1 is equal to P3. This is B2. This is P3. Right? So here process 2 3, B3 is equal to B1 is equal to 0.028 meter cube. Clear? and V2 is equal to 0.103 meter cube, right? And U2 is U3. U2 is equal to U3. Clear? Find out what on double 2 3. Now double 2 3 is equal to P2 V2 ln V3 V2. Clear? So this is equal to double 2 3 is equal to P2 V2. What is P2? Then P2, not P3, P2. Here P2, P3, beyond B3, B2. So what is P2 B2? P2 means what is P2? 140 kilopascal. B2 means B2, 0.103 meter cube. Clear? This is kilopascal. This is meter cube. Ln B3 or B2. What is B3? 0.028 by B2, 0.103. This ratio, so meter cancels. So this is meter square, 1 meter square cancel out. So kilonewton meter means answer is kilojoule. Clear? So double 2 3 is equal to, this answer is kilojoule. Double 2 3 is equal to minus 18.78 kilojoule. Minus 80.78 kilojoule. Double 2 3. Double 3 1. Double 3 will find double 3 1. Clear? Next process 3 1. Now here double 2 3 is equal to minus 8.70 kilojoule and B2 is equal to 0.103 meter cube. B2 is equal to 0.103 meter cube. Clear? Come to process 3 1. Now process 3 1. Process 3 1. Constant volume process. So double 3 1 0. 0. Therefore, total watt transfer. Total watt transfer. Sigma double is equal to double 1 2 plus double 2 3 plus double 3 1. Clear? So sigma double is equal to double 1. What double 1 2? 10.5 double 2 3 minus 18.78 plus 0. So sigma W. Clear? Sigma W is equal to minus 18.8.28 minus 8.28 kilojoule. This is total watt transfer. Next, come to total heat transfer. Clear? Total watt transfer W is equal to minus 80.28 kilojoule. Now come to total heat transfer. Similarly, Q12, Q23, Q31. We will find out Q12, Q23, Q31. Now, C and W is equal to minus 8.20 kg. Now, U13 is equal to minus 26.4 kilojoule. This implies U3 minus U1 is equal to minus 26.4 kilojoule. Clear? U3 minus U1. What is U1? But U3 is U2. U3 is U2. So this is equal to U2 minus U1 is equal to minus 26.4 kilojoule. Clear? This implies delta U12 is equal to minus 26.4 kilojoule. Right? What is Q12? Therefore, heat transfer Q12 is equal to W12 plus delta U12. So Q12 is equal to W12 by W12, 10.5 plus minus 26.4. So Q12 is equal to minus 26.4 plus 10.5. Clear? This Q12. U3 minus U1 minus 26.4. Clear? The U13. Yes. U13, U13 minus U1. Clear? U13 is equal to minus 26.4 kilojoule. So U13 means U3 minus U1 is equal to minus 26.4 kilojoule. Clear? U3 minus U1. Sorry. This U1 minus U3, not U3 minus U1. This is, sorry. This is U1 minus U3 is equal to minus 26.4 kilojoule. This implies U1 minus U2 is equal to minus 26.4 kilojoule. This plus U2 minus U1 is equal to plus 26.4 kilojoule. Clear? This is equal to delta U12 is equal to U2 minus U1 26.4 kilojoule. Right? This is the correct answer. So, what is Q12 is equal to? W12 plus delta U12. This is 10.5 plus 26.4. This is equal to 36.9. 36.9 kilojoule. Right? This is Q12. Here given U1 minus U3, not U13. Clear? U1 minus U3 means U1 minus U2, U2 is equal to U3. So U2 minus U1 is equal to 26.4. See delta U12. U2 means U1 U 26.4 kilojoule. Now this is correct answer WQ12. Then come to Q23. Now Q23. Q23. Here Q23 is equal to double 23 plus delta 23. So double 23. Double 23 means delta 23 means U3 means U2. So Q23 is equal to double 23 plus U3 minus U2. Here U3 is U2 given. So delta U23 0. So Q23 is equal to double 23. What double 23 is equal to? Minus 80.78 kJ. Minus 80.78 kJ. This is Q23. Next. Q12, Q23. Then Q31. This is Q12, Q2. Then Q31. Now, in process 31, what is Q31 is equal to? Double 31 plus delta 31. So Q31 is equal to double 31. Double 31. 0. Clear? Constant volume process. So double 31 0. This is 0. 0 plus U1 minus U3. What is U1? U1 minus U3. Minus 26.4. Clear? So Q31 is equal to minus 46.4 kJ. This is Q31. Now Q12, Q23, Q31. Now find out total heat transfer sigma Q. Therefore, total heat transfer sigma Q is equal to Q12 plus Q23 plus Q31. So sigma Q is equal to Q12 36.9 plus Q23 minus 80.78 plus Q31 minus 26.4 minus 26.4. Clear? So add all these quantities, we will find out sigma Q is equal to minus 8.28 kJ. Clear? From before, I found out sigma double is equal to minus 8.28. Now, sigma Q minus 0.28. Hence, sigma dq is equal to, or total Q is equal to total W. That is, sigma Q is equal to sigma W, or summation of Q is equal to summation W. This proves this question clear. This is very important, difficult question, not difficult, easy question, but important question. So try to understand. If any doubt, give comment, I will make clear. Next question 113. Now, this is question number 113. 113. Clear? This question is the following data relates to a 12 cylinder singulating two stroke diesel engine. 12 cylinder, number of cylinders K 12. Singulating N is equal to capital N, revolves per minute. Speed is equal to 150 rpm, cylinder diameter 0.8 meter, stroke of piston 1.2 meter, area of indicator diagram 5.5 10 to minus 4 meter square, length of indicator diagram 0.06 meter, spring value 147 megapascal per meter. Find the near quad transfer in kilowatt, means indicator power. Indicator power means rate of doing work. Net work transfer in kilowatt. Kilowatt means kilojoule per second. Clear? First write the given data. The given data is 12 cylinder, means K is equal to 12. Clear? Singulating two stroke diesel engine with speed N 150 rpm. N is equal to 150 rpm. So this is given singulating. So N is equal to 150 rpm. This is 12 cylinder. So K is equal to 12. Right? Now, cylinder diameter 0.8 meter, D 0.8 meter. Stroke of piston stroke L is equal to 1.2 meter. Area of indicator diagram AD is equal to 5.5 10 to minus 4 meter square. Length of indicator diagram LD is equal to 0.06 meter. Spring value S is equal to S is equal to 147 megapascal per meter megapascal. Right? Find rate of doing work kilowatt, means indicator power. Indicator power means rate of doing work. Clear? Now, first find out mean effective pressure PM. PM is equal to mean effective pressure. What is pressure? What is PM? PM is equal to AD by LD into S. Clear? Area of indicator diagram by length of indicator diagram into spring constant. What is AD? AD is equal to 5.5 10 to minus 4 meter square by LD. What LD is equal to 0.06 meter into S. What S is equal to 147 megapascal per meter. Mega means 10 to 6 clear Newton per meter square or meter, right? This is the mean applied pressure PM. So meter square cancel out meter. Now the answer is Newton per meter square. Clear? This is PM. PM is equal to by 10 to 3 5.5 10 to minus 4 by 0.06 into 147 into 10 to 6 by 10 to 3 kilopascal. Clear? So we'll find out PM. Hello? Now PM is equal to 135 1.35 10 to 3 1.35 10 to 3 kilopascal is equal to 1350 kilopascal. This is PM. Now we'll find out kilowatt. Indicator power. Now indicator power. PM is equal to IP is equal to PM LA NK by 60 kilowatt. Because here PM is kilopascal, so IP is kilowatt. If PM is pascal, then IP is watt. Clear? This is watt per second means rate of doing work is equal to indicator power. So IP is equal to PM LA. What is A? Pi upon D square N K by 60. So this is equal to IP is equal to PM means 1350 L. What is L is equal to? Length of stroke 1.2 meter pi a 4 in D square. D means 0.8 square. N means N 150 K 12 pi 60. Clear? This indicator power IP means rate of doing work in kilowatt. IP is equal to 24429 kilowatt. This is rate of work done. Rate of work done means indicator power in kilowatt. Clear? Question number 113. Next, number 114. Now, this is question number 114. Clear? Very short question, short simple question. The question is a cylinder piston arrangement with air at initial temperature of 30 degrees centigrade undergoes expansion process for which pressure and volume are related by the equation P to N constant, where P is this and V is this. 1, 2, 3. Find the total work done for the process. Clear? Find the total work done for the process. Now, this is 1, 2, 3. This is P1, clear? This is P2, this is P3. Similarly, this is B1, this is B2, this is B3. Clear? P1, P2, P3, B1, B2, B3. The process follows the law P to N constant. So we will find out N. From this value we will find out to N. Also given initial temperature T is equal to 30 centigrade. T1. What T1 is equal to? 30 degree centigrade. Right? First find out the value of N. Now P1 beyond N is equal to P2 B2 power N is equal to P3 with the power of N. Right? This is expansion or compression formula for polytropic process. This is a polytropic process. The process follows the law P to the power N constant. So find out what is the value of N. So P1 beyond N is equal to P2 power N. Taking ln both sides. Clear? Taking ln both sides. Now, ln P1 beyond N is equal to ln P2 to the power of N. So, bracket. Sorry. So ln P1 into P1 N is equal to ln P2 into N. So P2 B2 per N 1 P1 B1 per N. So ln means outside of this. Okay. This is ln P1 plus ln B1 per N ln P2 plus ln B2 per N. Right? So this is equal to ln P1 minus ln P2 is equal to ln B2 per N minus ln B1 per N. Clear? So the same place ln P1 by P2 is equal to L ln B2 minus L ln B1. Clear? So ln P1 and P2 is equal to L ln B2 by B1. N common. So what is N is equal to? N is equal to ln P1 P2 by ln P2 B1. Clear? Put all the values, will get n 1.4. 1.4. Clear? Putting all the values, we'll get n is 1.4. Then come to what done. Now, total what done? W is equal to W12 plus W23. So W12 Q1 V1 minus P2 by n minus 1 plus W23 P2 V2 minus P3 V3 by. Clear? So now P2 V2 P2 V2 cancel out. So W is equal to P1 V1 minus P2 V2 plus P2 V2 minus P3 V3 by n minus 1. So P2 V2 P2 V2 cancel out, right? So W is equal to P1 V1 minus P3 V3 by n minus 1. Clear? Put all the values from here, we'll get W is equal to 10.6 kilojoule. Put all the values, we will get W is equal to 10.6 kilojoule. Right? This answer for this question, very simple question. Also, some trick is here. You cancel this P2 V2. You find out n, then find the answer. Thank you. This is our question number 114. Next class, I will do some problems related to this theory. The problem is very important for GATE examination, before semester examination, also for diploma students. So you follow these questions and answers. If in doubt, write in comment. I will give answer. Thank you.